Hello, today we are going to solve one question based on design of experiment. So let's see what is in this question. In a Latin square design, the error degrees of freedom is 30. Now the treatment degrees of freedom we need to find. As we know that in a Latin square design, in a Latin square design, the model looks like this. Yijk is equals to alpha plus Ci plus Rj plus Tk plus Eijk for all I and j is equals to 1 to p and k is equals to 1 to p also. Okay, where alpha is the fixed effect, Ci is the column effect due to ith column, Rj is the row effect, due to the jth row, Tk is the treatment effect, of kth treatment, and lastly Eijk is error. Now the ANOVA table looks like for this type of design is as follows. First of all, we have a column named source of variation. Then we have degrees of freedom. Then we have sum of squares. Then we have mean squares. And lastly, we have the F statistic. So here the variation is due to treatment row and column. So first of all, we write treatment. The source of variation is from treatment. Now the degrees of freedom for this case is p minus 1 as the treatment as there are p treatments, and the sum of square is p multiplied by sum over yi double naught bar minus y triple naught bar whole square, which is nothing but SS treatment. Now here we have MS treatment, which is SS treatment divided by degrees of freedom. Secondly, we write the source of variation is from rows. It is the degrees of freedom is also p minus 1 as there are p rows in a Latin square, and the sum of square is p multiplied by y naught j naught bar minus y triple naught bar whole square, which is nothing but sum of squares due to row. And here we have m as a row. Thirdly, the source of variation is from columns of a Latin square. Degrees of freedom is also p minus 1, and the sum of square is p multiplied by y naught naught j bar minus y triple naught bar whole square, which is nothing but sum of square due to columns. And here we have m as column. Okay, now we have to find the variation due to error. Now the degrees of freedom of error is evaluated by subtracting all the errors of all the degrees of freedom due to treatment row and columns from the total degrees of freedom. As we know, the total degrees of freedom is p square minus 1. So the error degrees of freedom results in p minus 1 into p minus 2. And sum of square is also evaluated from subtraction. We subtract all the sum of squares due to treatment row and columns from the total sum of square, which is triple sum y ijs minus y triple naught bar whole square. Okay, which is called TSS, or total sum of square. And the if statistics is MS treatment divided by MSE. Now in this problem, we have been told that the error degrees of freedom is 30. So by the question, p minus 1 into p minus 2 is 30. So we have p square minus 3p plus 2 is equals to 30. And we need to find the treatment degrees of freedom. Okay, now the treatment degrees of freedom is p minus 1. Treatment df is p minus 1. Okay, now if we solve this equation 1, we get p square minus 3p minus 28 equals to 0, and from this we get p square minus 7p plus 3p minus 28. Sorry, sorry, here we write wrongly. Here we have minus 7p plus 4p, which is equals to 0. Therefore we have p into p minus 7, and here we have plus 4 into p minus 7. From this we get p minus 7 multiplied by p plus 4 is equals to 0. Now as p cannot be negative, therefore the right value of p is 7. Okay, therefore the treatment degrees of freedom is 7 minus 1, that means 6. So option 3 is the correct answer. Okay, So we have successfully solved this question, and that's all for today. Thank you very much.